Okay, now I'm going to show you the circuit and show you that there's energy inside these capacitors coming from, out of space, coming down, hitting the panels and charging the capacitors. So I'm turning on the voltmeter, and I'm going to just show you that there's current from both sides of the capacitor. Here, just show it on there, Corey. Like zoom in. Can you see the numbers? Alright, so right there it says 2.008, and if you look closely, it's starting to charge again. See, now it's like it was at 2.009, 2.010 now, 2.011. See, it's slow, it goes up slow, but it's going up. Yeah, now it's going to 2.012. Alright, so that shows, that's showing that there's current here, and that would be the reverse current. And now on the regular current, it shows you'll see that it's 1.7. So that shows like a regular voltage at doing the regular positive and the negative probe. So it's 1.7, and it shows that this is actually less than the negative voltage. I mean the reverse voltage. And now I'll show you that there's energy in there still. So I'm going to use a little buzzer here and show that there's like electricity flowing, and you'll hear a sound. You can hear it, but it's a really high-pitched sound. And even if you go on the other side, you'll hear a sound if it reverses. And just notice that the voltage is different every time. So I have to switch the sides. See? So there's energy coming down and being transferred into each capacitor. And one more test to show, Alright, now that I've went over, most of the circuit, I'll show you, the schematic / drawing of how it's working. So, like how I shown in the attic, we got 3 foot by 2 foot insulated HVAC plates, and those two are connected together onto the antenna wire, which comes down to my discharge / charging circuit. And so what I did is, you would have the normal voltage right here coming down and charging the capacitor and trying to get to ground, and then on this side you have the reverse voltage coming and charging this side of the capacitor, trying to go to ground. And then as you can see, the normal voltage is approximately 0.5 volts a day, and the reverse voltage is approximately 1 volt a day. I mean, it's a slow process, but it shows that there's an energy source that can make a sound, light things, and you can see it on the amp meter. The capacitors are TV capacitors. I accidentally, when I first started, I didn't have the right capacitors, so they're not the same right now, but it probably won't affect it if I use 2 of the same. So on the normal side, I have a 35 volt TV capacitor, and on the reverse voltage side, I got a 50 volt TV capacitor. And so I believe that the LEDs help control the positive and negative. So the normal voltage seems that it would be taking the negative charges coming down, and the LED holds that charge in there from being discharged by, say, a positive charge hitting it. And on this side, the reverse voltage side is probably taking the positive charges, and then the LED is holding that voltage there, so it won't be discharged by the negative voltage. So it's, you're taking the positives and the negatives, and you transfer them into 2 different areas. And that's really it for that. And so this is all connected here, and then we have the grounding wire, which is ran out my window here, and it goes down to a copper pipe, which is my ground pipe, and it goes into the ground, and the wire is wrapped around the copper pipe and hit into the ground. Going back to the circuit, the variables that I've been testing so far is insulating the plate, and I first tried just basic plate, and it showing that there was barely anything being charged. And I did a painted plate and with a latex paint, and it increased the amount of charge that was being put out, but it didn't, give as much to the capacitors in the circuit. And then I finally went to a laminated plastic, which I put like a little highlight. It's all over the plates on both sides, and that seems to be doing the job right now. And so I only got 2 plates, up there, 3x2, which is like nothing. That's a small little plate, and that's charging this. So when I first started, and before I just discharged this for you, the circuit, it was at about like 4.6 volts on my chart that I have. So I've been starting to keep tab on what I was doing. I mean, this is how I started before, and it was looking really, like a crappy thing, and I wasn't being able to record what I was, putting out. And so I made my own chart here, and you can see the variables. I do weather because weather seems to be an important factor in the amount of charge. Then there's the times, so I can record when and where. And then a number of sheets, which is supposed to be proportional to the amount of energy that's being taken down. So, common sense says the more sheets that I put up there, the more, energies that's going to come down, and probably the faster it will charge. So right now I have 2 laminated HVAC metal sheets, in which I have the type of sheet. I would like to do copper, but it costs too much right now. And I got distance from ground. I did that wrong. It's 30, approximately 30 feet, not 80. And then I did diode type, which is just the basic LEDs, and capacitor, 2 capacitors in different directions I have, and no batteries or motor, which that is just technically like when I took the sound and showing you it. That's what this was supposed to be. And then discharge circuit is just just like how to straight to the capacitor, or the special circuit I just made like a few days ago, 4 days ago. And then there's the ground type and the depth of the copper pipe. So I took the copper pipe and I hit it in the ground about 3 inches because the ground was really hard to hit into. And then here I got AC/DC voltage and millivolts and amps, picoamps, whatever. And so to show, to record over the days how much it has. So in the first 2 days, approximately 1 day, I had 2 volts. It's a slow process, but you have 2 volts now. That's pretty, high. And then, if you go back to here, the times, I just would randomly come by during the day and get the times, just whenever I'm, around, and then record what I have. So I started the 23rd, and then it was the 24th, Monday, and Saturday, then Sunday, then Monday, then Tuesday. And I just have some random times, but it it helps me write down the data. I was getting afraid that it might be the router downstairs that gives off radio waves, so I turned it off to see. And when I woke up in the morning, it was still charging, so it was about like 3.7, and then I woke up the next day and it was about 4.22 volts. So that ruled out that it wasn't the router giving energy to the plate. And so, that's a good thing to know, because it's not like I'm just siphoning energy off of the waves again. And then, throughout the day, so I got back and it was like 9:36, so I came over, and the reverse voltage was 4.6 volts and the normal voltage was 1.7 volts. And then I tested, with the sound and stuff, so it brought all that down. So it went down to like 2 volts and like 1 volt normal. I'll probably record that next. And that's it.